differential equations. Differential equations, as you know, have differentials in them. But what is a first-order linear differential equation? Let's start by giving the standard form of the differential equation. So if we have here, if we have here a function, we'll call it ax. So depends only on x. Could be x squared, x cubed, ln x, e to the power x plus ln x. Anything that depends on x times dy over dx plus bx times y equals cx. So ax, bx, cx are all functions of x that depend only on x. You can see here that the reason we call it first order is because we only have the first derivative. We don't have a second derivative in the equation. And we can see that it's linear because all the terms are linear in terms of y. In other words, the exponent of the derivative of y is 1, and the exponent of the y term is 1. We don't care about the exponent of the x terms. So that is how you spot a first-order linear DE. And the steps to do that are pretty straightforward. That's why it's one of my favorite types to do. Very straightforward. First step, I like to call it SF, standard form. What is a standard form? It's basically this equation, but dy over dx is all alone. In other words, I don't like having the ax there. I want to remove it. And how do I do that? I divide the whole equation by ax, and that will remove my ax easily. So it will be dy over dx plus bx over ax. Y is equal to cx over ax. That's it. That's my standard form. I can rewrite it in a more pleasing way. Pxy is equal to qx, because px, I can just say px is bx over ax, and qx is equal to cx over ax. I just simplified it. Now, second, this allows us to get the integrating factor, if. You see how it's simple? SF, standard form. If, integrating factor. Okay, what's the integrating factor? It's a function of x that is obtained by doing this thing. It's the e exponent to the power of the integral of px dx. But what is px? Well, it's right there. You just got it from the standard form. You just put it here. That's it. That's the integrating factor. You do the integral and you simplify. Third step is multiplying the equation by the integrating factor. Which equation is that? Well, it's the standard form equation that you obtained. This one. Multiply it by the integrating factor. And the fourth step is why we are doing all of that, is to get the product rule. Use the product rule. Remember the product rule of differentiation? To simplify. Simplify what? Simplify the left-hand side of the equation. Straightforward steps, always applied, always the same way. Let's use an example to make it clearer. Okay, let's see. First of all, how do we know this is a first-order linear differential equation? Well, first thing to see is that this is the first derivative. There is no second derivative, third derivative, or etc. So it's first order. Second thing to notice, the derivative of y is to the power of 1. The exponent of y is to the power of 1. We don't really care about the exponent of x. X could be anything we want. It's just the y that is what matters, right? So this means that this is first order linear, and we can go ahead and do step 1, standard form. Standard form means it's the same form as this, but the dy over x term, I want nothing to have with it. Like the x here, I want to get rid of it somehow. So how do I do that? I divide by x. I divide by x to get rid of it. Now I have dy over dx minus 4 over xy is equal to x to the power of 5 using the exponent rule, ex. Okay, great. Now we can see that the px is somewhere over there. The coefficient of the y term is right there, and that helps us to find the integrating factor in step 2, which is, as I said, e to the power of the integral of px dx. And px in this example is minus 4 over x. We just obtain it from here, and we put it right here. Minus 4 over x dx. And if you've known your calculus, you will know that this is just simply minus 4 ln x. We use exponent rules to put the minus 4 inside so that we can simplify this. The e and the ln will cancel out, and we will have x to the minus 4 as our integrating factor. Awesome. Now, the third step is to use this integrating factor by multiplying it with the equation. So we multiply it with the equation we have. So this is the equation. We multiply it, all of it, by x to the minus 4. What do we get? We get x to the minus 4 dy dx minus 4 over x to the 5 y is equal to just basic exponent rules, 5 minus 4 x ex. Oh, and now we can use the product rule. We realize, we notice that this is what comes after using the product rule of differentiation. And it is simply d over dx times the integrating factor multiplied by y. If you go from this step to this step, you can see that this is just the product rule for differentiation, where this is f and this is g. So this is f g prime plus g f prime. You see how it all relates? The product rule is really useful in this case because this helped us to regroup the terms together and simplify them. That's equal to, as always, x to the ex, right? Now we can just integrate both sides because that would help us to remove the d over dx. So we will end up with just this term in the middle is equal to, what's the integral of this? We can immediately see it's a product of two functions of x. We can use the integrating by parts. I have a nice method that we can use to make it like very easy, very straightforward. I put the term I put the term x here, I put the term ex over here, and I go down. And as I go down, this term, I differentiate. So what's the differentiation of x? 1. What's the differentiation of 1? 0. And when I go down here, and I integrate this, so ex, ex. Now what do? I create an arrow. That's where I'm going to multiply this term by this term, and I create an arrow like this. So I multiply this term by this term, and this term will be positive and this term will be negative. So it's going to be positive, negative. And if I had more steps, it would be positive, negative, positive, negative, positive, negative, and I just add them together. So I have x times e to the power x minus 1 times e to the power x. And there we go. Straightforward, easy. And now I can just divide the whole thing by x to the power minus 4. Oh, I forgot to include the c. Of course, when you integrate, always put the c. So x minus 4 and x minus 4. And now I have my solution for the differential equation in terms of y explicitly, which means that this is x to the power 5 ex minus x to the power 4 ex plus c times x to the power 4. And there we go. That's it. That's the solvability and the solution of a first order linear differential equation. Quick revision. We have to know that it's first order by looking at the first derivative and no second nor third derivative. We find out it's linear by looking at all the terms of y and the derivatives of y to have a degree of 1 maximum. And we do the standard form. We get the standard form by eliminating the coefficient of the derivative. We get the integrating factor by this formula. We multiply the whole equation by the integrating factor. And at the end, we use the product rule to write it as d over dx times the integrating factor multiplied by y. That's what you write inside the brackets. And from then on, you integrate both sides, you get rid of the d over dx, and you can integrate normally to obtain the solution. I hope you've understood, and if you have any questions, please don't hesitate to ask me. Thank you.